So the first type of reaction is the oxidation-reduction reaction. You should realize that you should know definitions of oxidation and reduction, and that reduction is actually the opposite of oxidation. So if you know one, then the opposite is the other. So let's take a look at the different types of definition. Oxidation can be defined as the gain of oxygen. For example, if I have this kind of equation and the magnesium has changed to magnesium oxide, that means that the magnesium has gained oxygen, and we say that the magnesium has been oxidized. The opposite would apply to reduction. So if copper oxide changes to copper, for example, that means it has lost oxygen, and that is reduction. In some reactions, we don't have gain or loss of oxygen. We could be talking about transfer of electrons. So you should realize that oxidation is loss of electrons. That means if I have something like sodium that has 1 electron in its outermost shell and it loses it and becomes Na+, that is an oxidation reaction. Now the opposite would be reduction. If I have something that gains 1 electron, for example, like chlorine, and becomes Cl-, this means that the chlorine has been reduced, and this is a reduction reaction. It could also involve loss or gain of hydrogen. So oxidation will also be regarded as loss of hydrogen if something like this in organic chemistry, if this is ethane changes to ethene, this is regarded as an oxidation reaction. Reduction would be the opposite. So here nitrogen gained hydrogen, the gain of hydrogen is reduction. Now, another definition involves oxidation number. Now, oxidation is the increase in oxidation number. You should know that oxidation number is actually the charge on the atom. So if I have iron 2 or Fe2 plus, we say that its oxidation number is +2. If that changes to iron 3, that is Fe3 plus, that means that the charge has increased from +2 to +3, that is oxidation. The opposite would happen if we're talking about reduction. The oxidation number decreases. So if I have Na plus, we say the oxidation number is +1. Now, Na without any plus or minus on it, we say that the oxidation number is 0. So Na plus to Na has changed from +1 to 0. That means the oxidation number decreased. This is called reduction. Of course, you should realize that that involves gain of electrons also. When Na plus changes to Na, it's actually gaining an electron. So that is reduction. Or if iron 3 changes to iron 2, that is also reduction. Now, a redox reaction is one that involves both oxidation and reduction. For example, this first equation, now what is happening? The copper oxide has changed to copper. That means the copper oxide has lost oxygen. Loss of oxygen is reduction. Now, the hydrogen, what happened to the hydrogen? It changed to H2O. That means it has gained oxygen. So we say that the hydrogen has been oxidized. Second equation, the Fe has changed to Fe2 plus. If we say with respect to transfer of electrons, well, that means that the Fe has lost electrons, and that is oxidation. If we say with respect to the oxidation number, well, the Fe has no charge on it, so the oxidation number is 0. It changed to Fe2 plus. That means it changed from 0 to +2. That is an increase in the oxidation number. That is oxidation. And we say that it is the Fe that has been oxidized. Now, copper 2 plus has changed to copper. That means either you say that it has gained electrons, or you say that the oxidation number has changed from +2 to 0. That means the oxidation number has decreased, and that is reduction. So a typical question would be something like this. Explain why this reaction is a redox reaction. We said, what's a redox reaction? It's one in which we have oxidation and reduction. So you have to tell me, where has oxidation happened? Where has reduction happened? Of course, the zinc to zinc 2 plus, that means that the zinc has lost electrons, or it has increased in oxidation number, so the zinc has been oxidized. the copper 2 plus has changed to copper. That means it has gained electrons, or the oxidation number has decreased. So this is the one that has been oxidized. Now, when something is oxidized or reduced, then there is something called an oxidizing agent and a reducing agent. So when a substance is reduced, it is the oxidizing agent, because when it is reduced, that means it gives its oxygen to the other one. So it is the oxidizing agent. So if we're looking for which one is the oxidizing agent, it is the reactant that has given oxygen or that has been reduced. In the lab or in experiments, if he says suggest the name of an oxidizing agent, remember that potassium manganate is an oxidizing agent, potassium dichromate is an oxidizing agent, halogens are oxidizing agents. You also have to remember that potassium manganate is something that changes from purple to colorless when it reacts. So if he tells me that compound A reacted with potassium manganate and changed it from purple to colorless, potassium manganate is an oxidizing agent. That means that the other compound is a reducing agent. Potassium dichromate is something that is orange in color. When it reacts with a reducing agent, it changes to green. Reducing agent, again, the reducing agent is the one that has been oxidized, or it is the one that gains the oxygen. That means it causes the other one to be reduced, so it is the reducing agent. If it says suggest examples of reducing agents in a lab, when we want to do a reaction in which we need a reducing agent, then we react that substance with hydrogen or with carbon, in the form, usually in the form of coke, or with carbon monoxide or metals. Because metals lose electrons, they become oxidized. The other substance that they're losing electrons to become reduced, so they act as reducing agents. So in this question again, remember we said that the copper oxide has been reduced, the hydrogen has been oxidized. So which one is the oxidizing agent and which one is the reducing agent? We said the one that has been reduced is the oxidizing agent. The one that has been oxidized is the reducing agent. Remember when he says which one is oxidizing agent, which one is reducing agent, we're looking at the reactants, not the products. So don't tell me the copper is an oxidizing agent or the water is an oxidizing agent. You're looking at the reactants. The second equation, remember we said from Fe to Fe2 plus, that is oxidation. That means the iron has been oxidized. That means that the iron is the reducing agent. The copper 2 plus has been reduced. So that is with respect to types of